Alright, it's time to take a look at this old drill press. This is a Sears Craftsman badged machine. Best I can tell, it was made in the early 1970s. I don't know who the original manufacturer was. It is a 15.5 inch drill press, which means you can put a piece of material in here that's 15.5 inches wide and drill in the center of it. So half of that, which would be 7 3/4 between the center of the spindle and where you run out of room at the column back here. When I got this machine, that's probably been about, I don't know, 15 years or so. It was a pretty rough shape. A lot of the parts were missing, but I didn't pay much for it. I recently took it all apart and just cleaned out some of those decades old grunge that was inside, and painted the castings and put it back together. And I didn't come with I didn't get it with a belt guard, but that's one of the more interesting things about this machine is the pulley system that it has. You know, most machines will have a 3 pulley setup in order to get a wide range of speeds. Well, they did away with the 3rd pulley on this one, and to maintain the range of speeds, they just crammed all the steps together and used a little skinny belt. And you would think that maybe a skinny belt like that would be prone to slipping, but I've never had that problem with it. It originally came with chrome handles with some plastic knobs on them, and I remember the chrome was all peeled off and they were real rusty and didn't look very good. So I took them off and I made these up to put on them. And I've since got these threaded balls. So I'm going to go ahead and make up a new set of handles for this thing and fix it up a little bit. Alright, the thread size on both sides of these handles are 1/2 by 13. Now I have a die that size, and normally that's what I would do. I would just run a die over them, but I think for the purpose of this video I'm going to try out some single point threading. So I'm going to go down here and get the lathe set up for that. I look on the chart down here and I find my threads per inch at 13, so this left lever is supposed to be in the 7th position. So 1, 2, 3, 4, 5, 6, 7. Move that over to that. And this one is supposed to be in the B position, and we're already set there. So we're good to go there, and just need to move the carriage drive from the carriage drive rod to the lead screw. Now you're supposed to set your compound at 29.5 degrees, so I'm going to set it up on this dial here, 29.5. And I also have this protractor set at 29.5, and I'm going to put it on the face of the chuck here, and I'm going to compare the two angles, and it's obvious they're not even close. So I'm going to use the protractor to set the angle on the compound. And I think especially if you have one of these Chinese lathes, I guess it depends on where they put their zero, but if you have one of these types of lathes, you probably want to check your angle with a protractor. Not too terrible. So I'm going to take them over to the mill and mount them in a collet block and mill flats on them so I can turn them with a wrench. I have a 5C collet block. Put that in a vise and snug it down. Here's the 5C collet. And I have all these handles marked so I can get all the flats in the same place. And I'm going to set up the mag base stop so I can take it out and get it back in the same position. Alright, I just want to get the spindle centered over that mark. Alright, I've switched the center finder out with an end mill, and I've done the math, and I figure about 32 thousandths off each side will let me turn it with a 7/16 wrench. Alright, I'll go ahead and get these on. Well, it's finished, and it's a fun project. It's been on the list of things to do for a while, and I'm glad I got it knocked out. I still want to make some little cover to go in here, and at some point I'd like to fabricate a belt guard for it. But those things will be down the road just a little bit because I got to get on to other things. So I'm gonna leave it right there, and until next time, thanks for watching.